कंप्लीट काम पेपर किया है।
Good afternoon.
गुड आफ्टरनून।
So I hope you all have seen the lecture video that I shared. It might be yesterday. I forgot that. I shared two of the lecture video yesterday, no?
Yeah.
So I hope all of you, you already watched the lecture video. So if you didn't watch it, then uh, it will be difficult for you people to understand today's class. So I hope all of you already watch it. And before that, before going to the relational model, continuing on our lecture for relational model, let us just see some of the work, some of the design you have done for hostel mess database. Okay. So I'll just tell you what you have done and where you have made the mistakes. So see, this is the requirement specification for hostel mess database, isn't it? Let us see some of the design. This is the first one. Here, almost everything is correct in this design. The only thing is here this type, this attribute means we are going to provide constraint on this type, means the value that should be entered for this type should be either girl or boy. Okay, girl and boy is the value that is going to be provided for this particular attribute type. Okay, so this is not some sub category sub attribute for this type, means this type is not a composite attribute. Okay, this is just a simple attribute, and the value that should be entered when it is, this is a design, isn't it? This should be, if we are going to use it, then we have to use this design and we have to create the actual database, isn't it? And in the actual database we are going to enter data, isn't it? So while entering data, what happened is the value that we are going to enter in this type attribute should be either girl or boy according to the hostel type. Okay, so you can't just give it like this, means it is not an attribute. Okay, so just this keep this type as a simple attribute. Other things are in the requirement specification for particular days you have to keep track of the things that is given for breakfast, lunch and dinner, isn't it? So either just put the day here as an attribute for this relationship, or the day as an attribute for mess menu. Okay. Okay, so mess menu, breakfast, lunch, dinner, and if we put the day as here as an attribute, then whatever possible combination that we are going to give for breakfast, lunch, and dinner, and in which day it is going to give, it will be entered. Okay, in the actual database. Okay, so you can do that either give the day as an attribute for mess menu or as an attribute for this has relationship type. Okay. Other things they are means I think they are all yeah, every other means all the other requirements are already represented here. So it is correct. The only thing is type should be a simple attribute and the day attribute. You should provide the day attribute because it is mentioned here in this requirement specification. Keep track of the mess menu of each hostel to record in which day. Okay, which day, in which day, in Monday, what items are giving, on Tuesday, what items are giving. So that is what just keep the day as an attribute or for this mess menu. Okay, so there will be many possible combination of breakfast, lunch, and dinner for a particular day, say Monday. Okay, so like that, and you can give this Monday as a partial key. Okay, for this mess menu because mess menu is in weak entity type, so you can just net the day as a partial key. Okay, partial key can be can have repeated values, so just give a partial key here. So this is the first design. Let us see some other few designs that you have done. The next one is here, this one. So one thing, just whatever means whatever I have taught, try to understand each and every component. So this hostel is an entity type, student is also an entity type, warden is an entity type. But here mess, I don't know what, if it is represented as an attribute, then you can't have a relationship between an attribute and an entity type. Okay, so this design, particular design is done without understanding whatever I have taught for entity relationship model. Okay, so the relationship, whatever relationship you have, it should be between entity type and entity type. Okay, you can't have a relationship between an attribute and an entity type. Okay, and if this particular mess menu you forgot to represent, it means you actually represent it as a entity type, but you forgot the notation, then why there is a direct link from hostel to mess menu? There should be a relationship, isn't it? Relationship between these two. An entity type and entity types should be linked together only if there is a relationship between each other. Okay, so there is a relationship between hostel C like this. Hostel and student, because of the relationship type stays in, isn't it? So try to understand the entity relationship modeling thoroughly. Okay, so this is a wrong design. Let us see one more design. Here again, how there is a link between a relationship type and a relationship type. You can't have means why this doesn't make any sense. Okay, so this is one design, and one thing I'm saying in few of the design here, this one and this one, what is happening is there is a relationship between hostel and student. Again, there is a relationship between student and warden. So I will just tell you one thing here. The student and the warden is related to each other because of the hostel. If a student is not staying in the hostel, then how the warden is related to the student? Okay, so there is an indirect relationship between student and warden because of the hostel. Okay, so that means there should be a relationship between hostel and student and hostel and warden. You can't have a direct relationship between student and warden. Okay, same thing for mess menu also. Student and mess menu is related only because of the hostel. He or she is staying in the hostel. That is why he or she is eating some thing that is given in the hostel, isn't it? Hostel mess. So that is why you can't have a direct relationship between mess menu and student again. Same thing for warden and mess menu also. Warden is working in the hostel. That is why it is related to mess menu, isn't it? Everything the means the everything because is means there is a direct indirect relationship because of this hostel. Okay, so a direct relationship is only between hostel and student, hostel and warden, and hostel and messman, like this. Okay, you can't have a relationship between these two, hostel and warden. Uh, sorry, student and warden. Okay, they are indirectly related because of this hostel. Okay, so this is the most this design so far. I have checked all the design, and I see that this design is somewhat related to the requirement specification that I had given. Okay, so the last design here again, there is a if there is a see this one again, there is a relationship between hostel and warden, isn't it? And there is a relationship between hostel and student. Okay, it means they are already related to each other. Warden and student, they are already related to each other. There is an indirect relationship between warden and student because of hostel, and these two relationship works and stay. Okay, so if you put another relationship here between warden and student, then data redundancy will be there for sure when you create the database actually. When you create the database actually using this design, data redundancy will be sure will be there in for sure. Okay, because of this relationship. Okay, that means I'm saying that this is just a common sense. There is a relationship between hostel and student, and there is a relationship between hostel and warden. That means they are already related. Students and warden are also already related. Because of these two relationship works and stay. So that means you do not need to have another relationship between warden and student. Okay, means you can see by this relationship stay, you can see for a particular student in which hostel he or she is staying, isn't it? Because of this relationship, isn't it? And because of that, again, you can see which warden is which warden is supervising the particular student. Okay, because of this relationship, isn't it? So you do not need to have another relationship here. It is going to be a redundant information in the database if you represent your design, if you represent your database like this. Okay. Another thing here is when I was explaining the requirement specification, I told you to either represent the mess menu as an attribute or as an entity type, isn't it? So if it is represented as an attribute, then just don't give this relationship here. The relationship should be between only entity type and entity type. You can't have a relationship between an entity type and an attribute. Okay, so keep all these things in your mind. And is there any more design here? Again, same thing. Almost all the other representation is correct here for this design. The only thing here again is this one. This one. If you have already there is a relationship between warden and hostel and student and hostel. So you do not need to have this relationship again, this control. Just remove this control relationship. Okay. And mess menu, this one, if you have represented it as an attribute, then just If it is represented as an attribute, then just it will be a composite attribute, and you just give another component here, day. Okay, so you need to keep track of the day also, so that is why I just put a day here. Other than that, all other representations, I think warden, then there's just give a key attribute here for this warden relation, warden entity type, and for student entity type also just give a ID or something in order to represent the key attribute. Okay, that is it. Whatever I have explained, if you are still having doubt while designing a database using entity relationship model, then you can tell me. Because this is the first step for designing a database. Okay, the first step is using the requirement specification, you have to design the ER model of the particular database. Okay, if you got the ER model, then directly by using the ER model, you can create your database. Okay, or you can convert it to the relational model, because relational model means whatever things for the database we have, it is represented in detail using relational model, isn't it? In the relational model, it is explained in detail. Everything is uh, means uh, means the relational model of a particular database is gives the detail about the database. So either if you are smart enough, you can directly create the database using the ER model, or convert the ER model to the relational model. After that, using the relational model, you can create the database, the actual database. Okay. So that is there is two ways of creating the database. So before creating, this is for just use it, means use it, think it as a compulsory thing. Okay, whenever you are going to create a database, first you need to design. So this step should be followed. Okay, this is same as creating a software. So while before creating software, you need to have a design of the software, isn't it? Same thing here also. Before creating your database, you need to have the design. Where the design can be either in the ER model or relational model or any other model. Okay, that is comfortable to you. So this is the first step. So if you are not able to understand this first step, then there will be some error or something, means the database that you created will be wrong. Okay, some inconsistency will be there in your database. Okay, so make sure you are able to understand everything that is given in the requirement specification, and using that requirement specification, you have to create, means you have to design. You need to have a correct design. Okay. So this is the ER model for your mesh database, and we have already started relational model, isn't it? So this again, this is also another model by using which you can have your design. So I have already explained all the terms and terminology that we will be using in this relational model. And in the lecture video, we already know how to convert a relational model to, how to convert an ER model to relational model, isn't it? Do you understand whatever I explained in the lecture video? Anyone? You need to respond. You need to respond for whatever I'm saying, because as this is an online class, I cannot see your face. That means I'm not able to, I means I don't know whether you are listening or not, whether you are there or not, whether you are present here or not. Do you, anybody, have you
Ma'am,
seen the lecture video?
I did watch, but not completely. There were some sections at the end side which I did not watch.
May I ask why?
Just it was rather late at night. I just slept while watching. So, uh,
Okay, so, and what about ER modeling? Are you
yes, ma'am.
people, are you people understanding
Yes, ma'am.
what
Yes, ma'am.
okay. So, yeah, to relational mapping. So this is a very, very long, very means it needs more than one class for this ER to relational mapping. That is why I already provide the lecture video first, so that you can see it, and then by using another example, we can do the mapping again. That was my plan. I didn't say anything because of some personal thing. So. Uh, I guess I have to explain it again. So let us see whatever is happening, what are the steps we need to follow for mapping ER to relational model. And you go through the lecture video again after this class. Okay, so that you understand it better, more better. Means this one, what happening is we are going to use the company database. The company database that I have given you, the ER model that we already designed in this class. This one. Okay. This one. Okay. So this company database, we are going to use it again and again. Okay, because while designing, we are going to use the same database again and again, even while creating means all whatever we are going to do. I will be using this particular example. Okay, so you need to have this entity relationship model with you. Just note it down in your notebook so that you can refer it again and again. Okay, so here how the mapping is done is, in the first step we have to follow the step also. You can't just skip some of the steps and go to the third step or the fourth step. You have to follow the steps here. Okay, to relational mapping. So whatever steps, if there is no such things like if there is no weak entity type, then you can skip this step number 2 in your model. If there is no weak entity type, then you can skip this step number 2. Okay, but you have to go through the step one by one. Let us see the first step. Here in the first step, mapping of regular or strong entity type. So whatever entity type we have in our model, if it is not a weak entity type, then it is a strong entity type or a regular entity type. Okay, regular or strong entity type. So for those E is representing the strong or regular entity type. Okay, so for this E, we have to create a relation R. Relation is the table. Do not mix it with the relationship of the ER model. Okay, this R is the relation of your relational model. Okay, so for those entity type E, you are going to create a relation R, that is the table R. And what attributes will be there in R is this one. You have to just read it out. The first one says include all simple attributes. Okay, all the simple attributes of E will be there in R as an attribute. Okay, and simple components of composite attribute. Okay, if there is any composite attribute in E, then whatever components of that particular composite attribute will be there as an attribute in R. You are not going to give, means you are not, say for example, in the company database, there is a composite attribute name, isn't it? Name of the employees. That is a composite attribute, isn't it? So you can't just put the name here as an attribute in R. You have to put the components of the composite attribute. That is the first name, last name, and first name, middle name, and last name as the attribute in R. Okay, so that is why include all simple attributes, it is saying, and simple components of composite attributes of E as attributes of R. Here, nothing is mentioned about multi-valued attribute, because for multi-valued attribute, we are going to do a different mapping style. Okay, so just if there is any multi-valued attribute present in E, then you just leave it there. Okay, just do not touch it. Okay, so you just need the simple attributes and simple components of composite attributes, and that will be placed in R as an attribute. Okay, so this is the first step. Other things here you need to do is choose one of the key attribute as the primary key. E might be having many keys. Okay, E might be having many keys. So from those keys, all of these keys are going to be candidate keys in R, isn't it? So from those candidate keys, just choose only a single key. Okay, just choose a single candidate key and make it the primary key of R. Okay, primary key of R. If the chosen key attribute is a composite attribute, okay, the set of simple attributes of the composite attribute will together form the primary key. So this is very simple. Everything is written here. If it is a composite attribute, means if the key attribute that you have chosen is a composite attribute, then the combination of the simple attributes of the means this composite attribute is going to have components, isn't it? So the combination of these components will be the primary key. Okay, it is going to be a set. Remember the set that you use in mathematics. Okay, so it is going to be, means the primary key is going to be a set of attributes, and the attributes that is contained in this set is going to be the components of the composite attribute that you have chosen as the primary key. Okay, so this is the first step. So from the first step, by using this first step, let us see what we can do. If you have already seen the lecture video, then we shouldn't do this again. So we should be able to directly map another example ER model to the relational model. So this from this ER model, the company database, we have 1, 2, 3 strong entity types, isn't it? Or regular entity types. So for this 3 entity types, we are going to use the step number 1, and we have to have 3 relations. The first relation is going to be the employee relation. Second relation will be department relation, and the third relation will be project relation. In the employee relation, what we are going to have as an attribute is SSN, birth date, FNAME, MNAME. This should be MNAME. Okay, this would be MNAME. So FNAME, MNAME, LNAME, address, salary, and sex. Okay, so these are going to be the attribute of the employee relation. Okay, and let us see the other relations, department. So for this department relation, the attributes are going to be name, number, and number of employee. You are not going to put this location as an attribute for department, because location is a multi-valued attribute, isn't it? So just ignore this one for now. Okay, and yeah, you need to choose the key attribute, isn't it? Here there is only a single candidate key, so you will be choosing this SSN as the primary key for the employee relation. Okay, for department relation, there is two candidate key. One is name and another one is number. So from this two, you have to choose only one and make it a primary key. Okay. For project, there will be three attributes: name, number, and location. Okay. And from this two candidate key, you have to choose only one and make it a primary key. Okay. So if we follow this step number 1, then let us see. By using step number 1, we have this three: employee relation, department relation, and project relation. This is a relational schema, isn't it? We already know what is relation schema. So this is a relation schema. So whenever we are designing a database using relational model, the design should be given as a relation schema. Okay. So this is the employee relation, whatever attribute here. And for department, we have this one. And for project, we have this. Okay. So according to the AR diagram we have seen just now, there should be another attribute here. And that is going to be number of employee. You can just put it. Just put number of employee as another attribute, and it is not a primary key. So just remove this line. Okay. So like this, you have to map the strong entity type or the regular entity type to the relational model representation, means to the relations. You can say there are three relations here, isn't it? So you have to map it like this by using step number 1. Let us see step number 2. Step number 2, mapping of weak entity type. So if there is any weak entity type in your ER diagram, W, then create a relation R. Here also we have to create the relation. Okay. And in the relation, what attributes we have to include? Let us see. Include all the simple attributes, simple components or composite attribute of W as the attribute of R. This is the same thing we see in step number 1. Okay. Next point is include the primary key attribute of the relation which correspond to the owner entity type as the foreign key. See here. When we have a weak entity type, we already know that it is depending on another strong entity type, isn't it? That means there is a relationship between the strong entity type and the weak entity type. Okay. So if there is any such relationship, then those relationships are represented by using foreign keys, referring foreign keys and primary keys. Okay, means foreign keys are going to refer to the primary key. So what we need here is include the primary key attribute of the relation which correspond to the owner entity type. Okay, primary key of the owner entity type as the foreign key in R. Okay, so remember this point. And the last one is the primary key of R will be the combination of the foreign key and the partial key of the weak entity type. Okay. So what will happen is from the ER model company database, here we have one weak entity type and that is dependent, isn't it? So for this dependent, again, we have to create a relation, dependent relation. And in that dependent relation, what attributes will be there? It will have name, sex, birth, date, and relationship. Okay, all the simple attributes will be just place it there as an attribute for in the relation. Okay, other than that, what will happen is we will be having another extra attribute, and that is going to be the foreign key referring to the primary key of the owner entity type, that is employee. Okay, so while we are creating the employee relation, what happened is we make this SSN as the primary key for the employee relation, isn't it? So this SSN will be there in this dependent relation. Okay, and here in this dependent relation, SSN is going to be the foreign key, referring to the SSN of employee relation. Okay, and the last point says that the combination of the foreign key with the partial key, that is name, combination of these two attributes is going to be the primary key of dependent relation, isn't it? Let us see what happened. By using this step number 2, okay. By using this step number 2, we will create this dependent relation. Dependent will have dependent name, sex, birth date, and relationship. These are the simple attributes of dependent and weak entity type, isn't it? And other than that, we also have another attribute ESSN, and this is going to be the foreign key, referring to what? Referring to the relation of the owner entity type employee. Okay, if this employee is the owner entity type, what will happen is the primary key of this employee is going to be given here as a foreign key. Okay, and the combination of this ESSN and the dependent name, that is a partial key, combination of these two is going to be the primary key of the dependent relation, that is the weak entity type. Okay, so this is according to our step number 2. Can read it again if you want. Okay, third step, let us see mapping of binary 1:1 relationship type. So whatever in step 1 and 2, we have done mapping for the entity types. Starting from step number 3, we are going to map the relationship type. Okay, so the first one is binary 1:1 relationship type. For binary 1:1 relationship type, what will happen is REL is representing the relationship that we have in our ER model. Okay, so for this relationship type REL, what will happen is there are two relations S and T. There are two relations S and T, which is representing the entity types. These are the relations. Okay, we already map it. We have done mapping using step number 1 and 2 for this. So we have two relations S and T representing the entity types, which is having the relationship between each other, means which is contributing to this relationship REL in the entity relationship model. Okay, if this is the condition, if we are having something like this, then what we can do is we can use 3 approaches. Okay, we can use 3 approaches. From these 3 approaches, you are going to use only a single approach. There is a relation. If there is a relation, are you people following me?
For some time there was silence.
Means I was unaudible. Is it?
For about 15-20 seconds when you started talking about the 3 approaches.
Okay, just wait. Okay, so what happened is this: if there is a relationship type which is having 1:1 cardinality ratio. Okay, if there is any relationship type which is having 1:1 cardinality ratio, then and the relationship is between this S and T. Okay, S and T's are not the entity type. They are the representation of the entity type, some other entity type. Okay, means these are the relations that we already map for the entity type which is contributing in this relationship type REL. Say for example, there is a relationship between employee and department, say works in, isn't it? So for employee also we already created a relation employee. Okay, and this S is representing that particular relation. This is not the entity type. This is a S is a representing a relation. T, same thing, T is also representing a relation. Okay, but the relationship REL is the relationship between the two corresponding entity type that is already represented by S and T. Okay, so if there is any such relationship, then what will happen is you can use either this approach or this approach or this approach, any of these three which is more comfortable with you, you can use it. Okay, so the first approach, I'll explain this three approach first. After that, you just choose which one will be comfortable to you. Okay, the first approach is foreign key approach. For this foreign key approach, what will happen is, here see the participation constant of the entity type. Okay, one might be having, say for example, if one is having a total participation and another one is having partial participation, and say for example S is having total participation and T is having partial participation, then include the primary key of T. Okay, include the primary key of T as a foreign key in S. Okay, primary key of T as the foreign key in S. So that is a representation for the relationship type REL using foreign key approach. The next approach is merged relation approach. So if both of them is having total participation, okay, even for total participation also you can follow the foreign key approach. But for example, if it is having a total participation, whether it is total participation or someone is having partial participation, it doesn't matter. But still, I'm just telling you, in the merge relation approach, what will happen is we are going to merge the S and T, S and T. And you can use merge relation approach only if both of them is having total participation. Okay, there is no restriction, such restriction in foreign key approach, but there is a restriction, one restriction in merge relation approach, that is both of them should be having total participation. If either of them is having a partial participation, then you cannot use merge relation approach. Okay, so just remember these things. I will give it as a notes also. Foreign key approach, you can use whether, means in any way, in any form, in any of the relationship which is having 1:1 cardinality ratio, you can use foreign key approach. But if you are going to use merge relation approach, you have to make sure that both of the entity type which is contributing in the relationship type REL, they should be having total participation. Okay. The last approach is cross reference or relationship relation approach. Merging this is very simple approach. Okay, you just need to merge with both of them, S and T, and after merging the primary key of S and the primary key of T, combination of those two primary key will become the primary key of the overall relation. Okay, overall merge relation. Okay, you can say the resultant relation after merging. The last approach is cross-reference or relationship relation approach. Okay. So for this one again, whether it is having total participation or partial participation, it doesn't matter. You can use this cross-reference relation again. Okay, there is no restriction for this also. So if we are using this approach, what we need to do is for this relationship REL, you need to create a relation R. Without involving anything, what will happen is you just create a different means totally okay, this one independent relation R for this relationship REL. Okay, so creating a relation for the relationship that is known as cross reference or relationship relation approach. Okay, so I will suggest one thing here. You can either use foreign key approach or cross reference or relationship relation approach, but do not use this merge relation approach. Okay, because this merge relation approach means there is many restriction for this. You cannot use for any other type of relationship. It should be for sure, it should be 1:1. Okay, and both of them should be having total participation. So I do not suggest this using this particular approach. You just need to know what this approach is, but you do not use this approach. Okay, so let us see how this approach work using the using our company database in the next class. So this is a very long process. So you in the next class, let us just try to go through the lecture video once, and then we will see how these approaches are used using some more examples. Okay. So far, some of the students have not attended even a single class. I don't know why is it, but they will be having a major problem here because this subject you will not be able to learn it means yourself. You just need some guidance for this. Okay, designing and all by just using some tutorial, you will not be able to follow it. And soon we are going to, after this relational model, we will be going to our SQL. So if we started our SQL, then soon this one your lab classes will be starting. Okay, so if the lab classes are started, then you will not means there you won't have any time to go through all this modeling, all this designing process and those things. You need to know how you are going to design your database before creating your database. So if you do not need to know how to design, then how you are going to create it? Just tell them all these things, because it will be very difficult for them to follow. Okay, response to attendance. A visit